So let's start with graphing, negative 2x plus 3. And remember, we're going to graph it on the left-hand side here. So negative 2x plus 3, go to positive 3, and negative 2x would be negative 2 over 1. So it's down to right 1. And we don't want to go to the right side because that's a different graph. So we're going to go back here and go up 2, left 1, up 2, left 1. There we go. But then on the right side, everything greater than 1, that's 1, 2, 3, 4, all these x's that are greater than 1, we're going to graph y equals 1, which is just a straight line. There you go. Okay. Would it be dashed? No. We are actually graphing y equals negative 2x plus 3 and y equals 1. The greater than less than is just to know what side of the line am I graphing on. Yeah. And again, this dashed line I put here you don't necessarily have to do. I was just trying to make the point of on the left-hand side of that line will be one graph, on the other side will be a different. So it's like graphing, two equations onto one axis, and that's called piecewise. It's kind of like different pieces of graphs. Not too bad. Not too bad. Alright. Let's see here. Any of these? Let's see here. Let's do 3 or 4. They're about the same. Now let's do 3. So let's try another. So this time, as you can see, the borderline is going to be at negative 2. So at negative 2, right here, right, to the left of this line will be this graph, 1/2 x minus 2, and to the right of that will be negative x minus 5. Two different graphs. If you prefer for this one, you see how it's written x divided by 2 minus 2. We're not used to seeing it written this way. A more familiar way of writing that would be 1/2 x minus 2. So the y-intercept is negative 2, the slope is 1/2. So just think of a 1 right here and just moving the x in front of the fraction instead of on top. Same thing, just written differently. Alright, go ahead and graph 1/2 x minus 2. Okay, go ahead and graph that, 1/2 x minus 2. But remember, you only want to graph it to the left over here. So you don't want anything on to the right of it at all. So what's negative 2, right? Y-intercept negative 2. Then it's up 1 over 2, up 1 over 2, but that takes me to the wrong side. I want to graph only from this point and that way. So I have to start at negative 2, but go down 1, left 2. Down 1, left 2. So you can see our habits would have us put a dot right here on negative 2 on the y-intercept, but remember we only want to graph this to the left of negative 2, so we don't want to put that dot. So you notice also how I had to change the slope to negative 1 over negative 2. I had to go down 1, left 2 to get to the place that is to the left of negative 2. Okay, there you go. Alright, actually I should have that blue. Alright, now let's graph this one. And we're only going to graph it to the right of negative 2. Alright, that's the same as negative 1 over 1x minus 5. So we start at negative 5, right here, and we're going to go down 1, right 1, just like this. We also want to go this way, all the way up to 2. So again, two different graphs on the same axes. Just on the left of 2 is one graph, to the right of 2 is another. So realize these numbers will always be like that turning point. That gives you that pivot point. Here's 1, and then at x equals 1, that's where it pivots and it turns. So that's the purpose of this over here, to tell you, well, where is this going to be going? Where is that line being drawn? Alright, good. Alright, so why don't you guys go ahead and do 2 and 4, or 2 and, let's see, let's look at the rest of these. These all basically the same. Yeah, you can do 2. Yeah, alright. Yeah. Let's actually just do, yeah, go ahead and do 2. Let's just do 2. Give that a go, try it on your own. So let's go ahead and graph the easier of the two, which is going to be to the right of negative 2. Remember, this is 1/2 x minus 4. And that's going to be starting at negative 2. So 1/2 x minus 4, that'd be up 1 over 2. And remember, we're going to negative 2, just right here. So there we go. So there's half the graph. Not too bad. Starts at negative 2. Remember, greater than means goes to the right, or this graph right here, it tells you that graph should be going on the right-hand side. But on the left-hand side, we have a quadratic, so it's not going to be two straight lines anymore. It's going to be a part of a parabola and then a straight line. So just a reminder, what would this parabola look like? What does this tell us? Negative x squared, what does that tell us? Yeah. So recall that if that number in front is negative, it's going down, negative 1. Oops. Snap back in it. Why is it doing that? There we go. Stay. There we go. And the y-intercept is negative 1. So k on the outside is negative 1. So that means we're going to have this graph right here, but it's only going to start at negative 2. So here's 0, here's negative 1 right here, so negative 2. So you're only going to have this graph starting here and going to left. You're not going to have the full vertex and everything. It's going to be that small little part. Okay, it's going to be that small little part. So one thing you could do is go through and graph the whole thing. Alright, do a T-chart and do whatever we need to do. Alright, so we have the parabola, but then, yeah, we only want this parabola from negative 2 and to the left. So that means all this other red part of the parabola that's to the right, we got to get rid of it. So we really only want just this. We just want that part. So it's like a straight line and then a little bit of a parabola. We don't want any of those dots or anything. We just want the part of the parabola that is to the left of negative 2. So you're only graphing negative x squared minus 1 to the left right here of negative 2. But if it helps to do the whole thing and then like erase what's not to the left, that you can do that as well. Sometimes that's a lot easier. It's hard. It's almost impossible to say, well, I'm just from the very beginning just going to graph negative x squared minus 1 just from here to the left. Nobody was going to graph a parabola like this. So graph the whole thing and then just take off what's not to the left. Okay. So your final, if I had to graph this, wouldn't have any of those dots. Your final answer would look just something like that. So hopefully we're okay and comfortable with the notation. We're okay with finding this point, and that's like the pivot point, or sometimes a point where it jumps. They don't always meet. Like these graphs so far have all been meeting at the same point, but sometimes the parabola might be up here, and then the line starts down here, and there's a little space between them. That's okay as well. But at least we know that's where the change is happening, is at the value here. These numbers are always the same, as you'll notice in every problem. So when one graph stops, another one is going to start. There's not going to be some gap where there's no graph. Okay. And let's see here. Anything else? I think that's about it. And you're going to have to do a little bit of work on some of these to graph the quadratics. You're going to have to maybe make a t-chart or do some of the work we did before in Algebra 1 in order to graph these, whether it's find the vertex, put in vertex form, whatever it takes. Think of it as a little bit of review built into this assignment. You're going to need it for the final for sure. So it's a good thing. So I'll do one more. Any requests looking at the front and back? Something from the back. We haven't done anything on the back yet.
Number 9.
Number 9?
Actually, no. I get that.
Okay. Any others? Which one? Number 9? Okay. So get 9. Alright, so negative 1/2 x plus 1/2, starting at to the left of x equals 1. So right here, alright, to the left will be that. And then to the right will just be y equals negative x. Y equals negative x to the right. That's a little bit easier. Just remember it's y equals negative x, which is negative 1 over 1x plus 0. So we'll start here. I'm not going to put a dot because I only want to start it to the right of 1. So I know the graph starts here. I'm going to go down 1, right 1. Now I'm going to put a dot. Alright. There we go. Only to the right of positive 1. To the left, I'm going to have this negative 1/2 x plus 1/2. So a little weird at this. My y-intercept is a half. That's okay. We can start here. Add a half between 0 and 1, and then go. Let's see. Down 1, right 2. Down 1, right 2. All right. Yeah. I'll put a little dot. I can also go up 1, left 2, up 1, left 2. Notice how I'm always going to be in the middle since I started at a half. Up 1, left 2. And if I connect those, you'll notice that they don't quite meet. This is what I was talking about earlier, that sometimes the graph will meet just exactly at the same point, but on these they don't actually connect. This is where it's important to see, well, which one is the equal to? So since this one's the equal to, the red one actually, I should use red. This is the equal to, that's where you want the dot. Right? And then over here, since this is not, that's actually going to be an open circle. So you remember that from inequalities? Sol dot, open dot. So that's where it makes a difference. If they don't actually meet each other, you got to have one open, one closed. They can't both be closed because then technically it's not a function anymore. It won't be a function. All right, so I think that will do it for you. Again, probably the most difficult thing is really just remembering how to do the quadratics, graphing parabolas, and what the parabolas look like. Okay. I think we can finish that up. So let's take the rest of the period and maybe a little bit of tomorrow to go over it. Tomorrow we'll do a review of everything, a lot of stuff about rationals and asymptotes, and step functions, absolute value functions, and shading inequalities. We'll do that all tomorrow review, and then Thursday take a test. And then we'll be wrapping up the year.